Okay, so I hope I'm live. Okay, so let's talk about the problem today. The problem that we have today is loop reconnect. So before talking about the problem, the part that I want to talk about is that we need to attempt the questions in a way like we need to discuss over here. We need to discuss how we need to attempt the questions when we are given these questions in interview. So there are two important things that we will discuss today. One is how to attempt question, and other is we will focus on the question itself. So these are two things which are very important and that we will focus on today. Okay, so let me quickly share my screen and then we can discuss about it a little more. Okay, so I hope the screen is now visible and you can see the event that we had was this live session on interview problems asked at Google. And as soon as you go into the classroom to this session, you would be able to see this course overview tab where we can have the discussion. Over here, I had already told you about the question that we are going to tackle today. And other than that, I have given you these questions to practice over here as well, right? Uh, let's look into the question as well. So this is the question that we have. You can directly go to our code studio and you can attempt this question, right? So the question that we have today was asked in Google, and the question is, let me pan out a little more. So the question is that you are given a linked list which has a loop in it, right? You need to focus on all those things which are given to you, right? So let me quickly take this problem description that we have over here onto the board that I have. So let me quickly take this part from here. So just a second. Yeah. Okay. So let me take the problem statement. Mhm. Now I am able to take it. Perfect. Let me take it this much part only. Okay. So you need to underline each and every part which is given into the question. So over here, what is given is we are given a linked list with a loop. You are given that there is a loop already. And all the elements, all the data elements that we have are unique, right? If the loop starts at node X, then we have to break the loop from the last node and we have to join it to a node which is just greater than X, right? If there is no such node which is greater than X, then what we have to do is we have to connect it to null, right? So we just need to return the head of the new linked list and we don't have to print the elements. Okay. Now let me explain this question to you. So let me take an example for you. So this is a linked list which is given to us. Let's suppose 1, 2, 3. It's given that the linked list has a loop. And the other point which is given is that all the elements are unique. These are two things which we need to underline. We need to have in my mind. So having a clarity over each and every aspect of the question is important. That's the first thing that you need to take care. So let's suppose these are the linked list nodes that I have. And let's suppose the loop that I have starts from 8 and let's suppose it combines with 5. And since this is singly linked list, so let me just make those connections as well. Now these are nodes. So nodes have reference, they have address. So let me give them hypothetical addresses. So let's suppose this has an address of 4K, this has an address of 5K, this has an address of 6K, this has an address of 7K, this has an address of 8K, then 9K, then 10K, and then 11K, right? So what I need to do is in this question, I need to locate the start point of the loop. If the start point of the loop is connected, is let's suppose X, and obviously the last point would be connected to the start point. So I need to break this loop and I need to connect it with the node which is just greater, right? So which is just greater than x. So I need to make connection with this node. So this is what I need to do in this question, right? Now we have understood the question pretty well. Then after we have understood the question, then the point comes where I have to start solving this question. And before attempting the question, what you need to have a clarity on, you need to have clarity on the question. So you can ask as many test cases as possible. You can ask 2 3 test cases. You can ask as many questions as possible to the interviewer. Like you can ask him to give you a few test cases. That would be a generic query that you can ask in every question. You can ask some deep questions as well, something which are very specific to this question only, right? So that's one thing. For example, if you don't find any node which is greater than x, here it's 5, then what you should print? It should be the answer should be -1, and the connection should be made to null. So that kind of a questions which are specific to this question. Okay, now let's move ahead. So now since we know about the question, now let's try to solve it. Okay, so it was given that earlier this connection was made like this. So what we need to see over here, we always need to find some or the other brute force solution to the question. What I think over here is I need to remove the loop, and then I need to remove the loop. After removing the loop, I need to find the appropriate connection where I can reconnect the loop, right? So from where do I need to remove the loop? That's one point. So I think I need to find the start node first. So let's try to break the question and let's try to write it in plain English. So first thing, I think I need to find the start node. I need to find the start pointer of the loop. After I have found the start pointer of the loop, then the second thing that I need to do is I need to find a node which is just greater than the start node's data. So just greater than the start node's data. So I should write like this. After I do that, I should have a pointer to the last node as well. So I think I should find the pointer to start node as well as to last node. Both these pointers I should find. It's not sufficient just to find the pointer to the start node. I need to find pointer to the last node as well. After that, I need to find the node which is just greater than the start node. After I have found that, then I need to make the connection from last node to that just greater node. So I need to make the connection from last node to just greater node. Let's name it last node and just greater node. That would do the part. Now let's talk about these aspects only. Now let's try to solve these three partitions that I have made. Now let's try to solve it using any solution that comes to your mind. So the first solution that comes to my mind, if I need to find the start node. So let me keep it over here. Let me find some space. Okay. So for start node, what I think is I need to find first one way that I can do to find the start node is that probably I can use my fast and slow pointer, right? So when I use my fast and slow pointer, just to elaborate for people who don't know about fast and slow pointer, I'll quickly give you an analogy with which you would be able to grasp what is fast and slow pointer. Let's quickly take an analogy. So let's suppose this is a racing track, and let's suppose the racing track is of 200 meters, and let's suppose there are two people. Let's suppose B is one person and A is another person. They are running, and let's suppose when B takes one stride, let's suppose it covers 1 meter, then A covers 2 meters, right? So A would be able to complete the complete distance of 200 meters in just 100 steps, right? And B obviously would take 200 steps. So what I need to say over here is let's try to do a small variation to this whole playground that we have over here, the whole track, let us create a loop over here. So what would happen? A would start running from here, and it will keep running in this loop, right? It will keep running in the loop. Obviously, B is also running. B is behind, and it would basically, in the beginning, it would be following it, but at some instant, they would collide, they would meet, right? So if they're running like that, they would meet somewhere. So that is the whole concept that we use in fast and slow pointer. We would be taking two pointers over here. Let's name one pointer as slow, and let's name the other pointer as fast, right? So after we do that, what we are going to do is we are going to move our fast pointer by two steps ahead, like this. In one iteration, I will move it two steps ahead. In one iteration, I'll just move it one step ahead. This way, they will meet somewhere or the other, because it's given that there is a loop. It's given that there is a loop. So that's why they will meet somewhere or the other. Let's say, for example, let's take that this is the point where they meet. So if this is the point where slow and the fast pointer meet, then what do you think? Would I be able to detect the first pointer? Would I be able to detect the start node with the help of that? It can be any node where slow and fast pointer meet, right? Let me tell you a brute force way to find the start node once you have collided at some or the other place in the loop, right? So let me quickly draw this loop again, quickly draw this whole diagram again. Perfect, perfect. And this gets connected to, let's suppose, 5. Okay, so let's suppose both of them have collided at 7, right? Both of them have collided at 7. So what I will do is I'll take a third pointer. Let's take a third pointer and let's start that pointer from this place, right? It's basically at head pointer. So what I'll do is I'll start from this place again. So this is, let's suppose, let's name it as head. Let's name it as head. And over here I have the slow, and over here I have the fast pointer. So I will leave slow over here, and I will move fast, and I will ask, is it possible to basically reach the head pointer from the fast pointer? I cannot reach. Starting from the fast pointer, I cannot reach the head pointer. So I will start, I'll go to 8, then I'll go to 5, then I'll go to 6, then I'll again go to 7, 8. I'm stuck in a loop. You can see that, right? So the fast pointer cannot reach head pointer from here. Like head cannot be reached. Then let's move ahead. I'll go to the next pointer. I'll move my head pointer, and let's suppose this is my head pointer now. Can I reach to head pointer from here? From fast pointer, I cannot reach to head pointer. And similarly, let's move ahead. I'm trying to find that first person. I'm trying to find that first node which would be reachable from the fast pointer. Obviously, 3 also cannot be reached. If I make it the head pointer, 3 also cannot be reached. I'll try to go to 4. 4 also cannot be reached from the fast pointer. So let's move ahead. 5, if I reach to 5, now let's try to find this. Obviously, I can reach till 5. So to find the start node, what I can do is I can basically write a function. Is it reachable? Is it reachable? Like I can give two nodes as an input. One is fast pointer, another is the head pointer. So I can name the function, is it reachable? From fast pointer, is head reachable? This is a small function which you all can write, right? It would return true or false, right? Whichever is the first node which is reachable for the fast pointer would be my answer. It would be my start node. So the second point that you need to focus on in problem solving is you need to break down your problem, right? This is the first breakdown that I had done, right? After that, to find start node itself, I'm breaking it down to further subdivisions, right? So that's the second thing that you need to do, right? Okay. So what I need to do now is I have found the start node, right? After that, finding the last node is easy, right? Finding the last node is easy. So what I can do is, this is my fast pointer. I can move my slow pointer again over here, right? Or what I can do is, I can basically say that fast pointer can be kept one way ahead than slow pointer over here, and slow pointer can be moved to the start node. And then basically what I can do is, I can take these two nodes and I can move them step by step, right? So probably I would need a third pointer as well. So a third pointer points to the start node. A third pointer points to the start node, right? Now we need to move these two pointers in continuum. So S points to 5, and let's suppose F points to 6. Let's move ahead. Now I'll take them one step ahead, right? Now S points to 6 and this points to 7. Okay. But still, I would stop when my F points to F5 again. My F points to start node again. Then I'll stop. Then my start node will be pointing to the last node, right? That's what I will do. So still that condition is not met. I'll move my start node over a slow node over here, and I'll move my fast node over here. Still my fast node is not equal to the S node, start node. I'll move a little bit ahead. Then I'll move my F node over here, and my S would be one way behind it, right? So now my fast pointer is equivalent to the start node. And at that point of time, my start node is pointing, my slow node is pointing to the last node. That's how I would be able to find my last node, right? Start node I have already found. Last node I can find like this, right? Now I want to move to the comment section, and I just want to see uh, if you have any doubts up till this part. So if you have any doubts up till this part, just let me know. I think this approach is clear to you. It's pretty simple. I'm just focusing on the first part of the problem, which is finding the start node and the last node, right? Just a few confirmation in the chat section would be really great, right? So if you have any doubt, then just let me know in the comment section. What I'm trying to do over here is I'm just proposing a brute force solution to find the start node. And after that, I have tried to find the last node. So the first thing that we have done is I have found the start node and I found the last node. But obviously, let's try to see the complexity. Then only we will move to the other subparts. Over here, what you can see is, first I started to find the start node. First I started with the slow pointer and the fast pointer, right? And I tried to find where they meet. So that's the first part that I did. The second part that I did was, after they had met at a point, after we have met at a point, then what I did was I basically tried to write this function. Is it reachable? From head to fast, is it reachable? I think this function, if you know, fast and slow pointer approach to find a loop, to detect a loop, is order n, right? The second part that we have written, it would take order n square in the worst case, right? And with the help of these two parts, I can say I'm trying to find the start node in order n square, which is very bad. N square is very bad. We have to bring it down. So last node, obviously, once I found the start node, then after that, I'm traversing with two pointers and I'm finding the last node. So I can say that I'm finding the last node in order n. Let's try to find the start node with a better complexity, right? Once we find the start node, then probably in a better complexity, then probably we can move ahead, right? So let's try to do some other way. Let's try to see if we can take some extra space, and then probably if we can find the start node. So we will try to optimize the complexity by taking extra space, right? So, so let's try to solve this problem by taking some extra space. So what I will do over here is I will point, I will try to create some copy nodes, right? I will try to create some duplicate nodes. So one would be, let's name a temporary node, and let's name let's give it a value. Let's create the same node one. Let's create a duplicate node. So rather than directly connecting one with two, I've created a duplicate node, and this is how I have done this part, right? Then I'm trying to create duplicate nodes for everybody, right? The first person for whom duplicate node is already there, that would be my start node, right? I'm just trying to reduce my complexity from order n square to order n, right? Okay, okay. So what we need to do is we basically would create some duplicate nodes over here. So let's quickly create some duplicate nodes. For each node that I'm going, I'll try to create the duplicate node. So 4 doesn't have a duplicate node, create the duplicate node. This is the duplicate node that I've created. 5 doesn't have the duplicate node, create the duplicate node, right? Then 6 obviously doesn't have the duplicate node, create the duplicate node. 7 doesn't have the duplicate node, create the duplicate node. 8 doesn't have the duplicate node, create the duplicate node. So a duplicate node would be created, and then this 8 would be connected over here. Then after that, I go to this node. I would try to create a duplicate node for this 5, but the duplicate node is already created. That's why I have found my node. I have found my start node. The problem with this approach is it is space expensive. It is space expensive. For each node, I'm creating a new node. So I'm taking order and space, right? But what I found in this part is I would always get some or the other insight to solve the problem in in better time complexity as well, and with the least with a better space complexity as well. First, try to solve it by brute force, then try to reduce the time by taking a little more space, right? So let's try to find the approach which has less space also, which has constant space also, and which is trying, which finds the start node in order n as well. All the questions of linked list needs to be solved in order one space complexity, right? Most of the questions, I would say 95 to 99% of questions, most of the questions that I see in linked list, they need to be solved in order one space complexity, right? So let's take another page over here, and let me quickly draw the diagram again, right? One thing that I want to utilize over here is I am not utilizing the fact that how many nodes I have in the loop, right? So I would try to utilize how many nodes I have in the loop, right? So the first thing that I will do is obviously I would basically loop in. I would use the slow and fast pointer. I would go into the loop. I would find the node where slow and fast conclude, coincide. I would reach over here. Then I would keep one pointer over here, and I will move the next pointer. Next pointer will go over here, then over here, and then it will again reach over here. By this, I would count the number of nodes that I have. Let's suppose there are 4 nodes over here, right? So if I have 4 nodes in this loop, so I've just counted the number of nodes that I have. After I have counted the number of nodes that I have, then what I'll do is I'll start again from the starting, right? And I will again take 2 pointers, one starting from here, other starting 4 distance ahead than it, right? I would keep count number of nodes difference between them. Over here, there are 4 nodes. Let's suppose there are m nodes in the loop. Then I will keep a space of n nodes between them. And then I will move them one by one. there is a difference of m nodes in between them, and there are m nodes in the loop. Once it will complete the loop, it will come back to the starting point, and in that meantime it will complete the linear distance between them. Don't you think if I keep the space of m nodes between them, and if I keep moving them linearly, I would be able to reach to the same node, and that node, mind you, would be the starting point of the loop. Let me take another example for you. Let me take a bigger example. Okay, so let's take 5, 6, 7, 8, 9. Let's take 10. Let's take 11. Let's take 12 over here, right? And let's loop in like this. Let's make this pointer like this, right? There are 4 nodes over here, right? So I'll start from here, keep a difference of 4 nodes, and this would be my second pointer, right? Let's change the color of these pointers. Let's take it, let's make it red, and let's make it red. Okay, or let it make it white. Let's make it white. It would be easier to detect. Now what I'm doing is I am keeping the difference between them exactly equal to the number of nodes in the loop. Now after that I will keep moving them one by one. So this will go ahead, it will reach over here. This will go ahead, it will reach over here. Then this will reach to third node, it will reach to the seventh node. Then this I will again take to fourth node, and this I'll again take to the eighth node. Then I'll move it to the fifth node, and then I will move this pointer to the ninth node, right? Uh, I'm naming the previous node as S, and I'm naming the forward node as F. Okay, so I'll move the S pointer over here, I'll move the F pointer over here, I'll move the S pointer over here, I'll move the F pointer over here. I'll move the S pointer over here, and I'll move the F pointer over here. I'll move the S pointer over here, and the F pointer will complete its loop and it will reach over here. So both of them coincide, and both of them will coincide at the starting point. That's the important thing that I wanted to talk about, right? So by this method, by counting the nodes, I can find the start node in order and complexity. Because both of these things, what I have done in this loop is, the first thing that I have done is I have found the coinciding point using the slow and the fast pointer. Then I have looped only in the loop, and I have found the number of nodes, which are m. After that, after finding the number of nodes in the loop, I have again traversed in the loop. I have again traversed on the linked list, and that was a single traversal. And with that help, I was able to find the start node. So this is order n, this is order n, this is order n. All the 3 steps are order n. So finding the start node would be order n. Then, as we discussed earlier, we can find the last node in order n. My space complexity is constant over here. I'm using constant number of variables to find the start node and the last node. So I think this is how you will find the start node and the last node. And the complexity is also clear to us. Now let's move ahead. Now let's talk about the next part. So first was finding the start node and the last node. Next point was finding the just greater node, right? For that, what I need to do is I just need to loop inside the loop. I just need to traverse inside the loop. So if this is my 1, 2, 3, 4, and let's suppose this is 5, this is 6, this is 7, this is 8, and let's suppose this is the connection. I have the start node. I can start from this node, and I can traverse each and every node, and I can find the just greater node. Let's take this as null to begin with. Let's take a variable. Let's name it as just greater node. Let's name it as 4k. Sorry, let's start traversing it. Let's start traversing from the start node. So I would start from here. I need to find just greater node. So I would traverse 6. Is 6 greater than nodes data? Start nodes data? Obviously it is greater than that. So I would change the address from null to whatever address I have over here. So let's give some hypothetical addresses. Let's suppose I give it 4k. Let's suppose I give it 5k. Let's suppose I give it 6k, and let's suppose I give it 7k. So 5k would come over here, right? Then I move to 7. 7 is also greater than 5, but whatever I have got, it is greater than this also. I just need to find just greater node. So just greater than 5. 7 is greater than 5, but it is not just greater. Something is smaller. So I need to find that node which is smaller than 5k. 7 doesn't qualify. I would not update it. 8 doesn't qualify. I would not update it. So after that, I'll again come back to the 4k, which completes my loop. So in one single traversal of the loop, I was able to find the node which is just greater than the start node. So in single traversal, I can solve this part as well, right? After that, what I need to do is I have found my start node, I have found my last node, and I have found my just greater node. I just need to say last node, the next pointer of the last node would be updated to the pointer of the just greater node, right? So this is how you solve the question, right? This is how you solve this question. So I wanted to point to this part. And this was a question which was asked in Google, and it was asked in one of the interviews in Google. And you can see, if you have the right basics, if you understand the fast and slow pointer really well, you would be able to solve this question. You would see that as such, you didn't need to know fast and slow pointer in this question. You didn't need to detect the loop. But still, if somebody knows how to detect the loop using fast and slow pointer, he would be able to solve this question optimally. First, he will detect the loop. From detecting the loop, he will count the nodes. By counting the nodes, he would find the start node. After finding the start node, he will find the last node. After that, he will find just greater node. And after that, he would basically connect last node and the just greater node. That's all that we had to do in this question, right? So that's about it. That's about it. Uh, it's something that uh, if you are not able to understand, if you feel that there is some part which you didn't understand, please rewind. Please go through the whole video again. You would be able to understand, comprehend the whole concept. If you were able to understand, then it's well and good. You can also go through the solution which is given over here, and apart from that, you can go to the questions to practice as well. I have kept another question which is very similar to the question that we have just discussed. Other than that, you can use this course overview tab over here, right? Use this course overview tab, right? Add whatever you want to ask over here, add all the doubts that you have, right? And try to explain it. Let's suppose you want to understand this concept pretty well, to try to explain this concept over here. By teaching, you would be able to understand this concept in a much better way. If you have any other approach to solve this question, please share it on the course overview tab, right? So that's about it. This was one question that I wanted to explain today, and this was asked in Google interview. The next thing that I want to talk about is try to attempt this question over here. We will be rolling out Amazon voucher for the first three submissions. So the first three submissions to this question would be given Amazon vouchers, and we would be contacting the people who have registered for the event and who are one of the first three people to submit this account. Other than that, one other thing that I wanted to talk about is, just like the Google interview question event that we have done just now, we would be rolling out this 30-minute question discussion every week. So the next discussion would happen on 15th, and next obviously would happen on 22nd, and we would be having one question, right? But for this part, for the question that we have discussed today, I would reiterate that the question was to reconnect the loop, right? and reconnect the loop. If the loop is connected from behind to X, then I have to reconnect it and I have to connect it with an element which is just greater than X. That was the question. And for that, what I did was I first found the start node. After that, I found the last node. After that, what I did was I found the just greater node. And after that, what I did, I made this connection from last node till to just greater node. These are the three steps that I did. Right? You have to be that kind of a problem solver who sees the problem, breaks down the problem, and then takes each and every component of the problem and solves it individually. Try to be as much modular as possible in your approach to solve the problems. Okay, I hope this session was useful for you. If you have any more suggestions, if you have any more comments, feel free to put it on the course overview tab. I would be looking after the course overview tab. I would be answering your questions on course overview tab. Right? Okay, thank you for listening. Okay.